Right, today we're going to be accurately drawing curves, including quadratic curves as these examples are, but they might be more complicated than the work you're going to do. The principle is the same throughout. I'm going to pre-warn you, there are a lot of repetitive steps here. They're each on their own very simple, but you've got to do them a lot of times to get the right result. So, we've got an equation up here which has a y in and some x's floating around. When we have x and y linked together, that should be ringing coordinate bells in your head. There's an x and a y that join as a pair to put on a graph at some point. So we're going to use this equation to find some coordinates, and we've been told to only use x values in this range, in this domain, between -3 and 5. Then we can either start at 5 and work down, or start at -3 and work up. I'm going to start at 5 so that we have reasonable whole numbers to begin with. So I'll do some colour coding as well to try and keep things matched up. So the x is the variable, which means that's going to change each time. So I'm going to get that redded up. So that's a red there, and that's a red there. So those are going to change every time. And depending what they are, we'll get a different y out. So this is our input, this is our output, is normally how we think about this. So we're going to start with 5 as our input for the first time, because we're starting at the big number first for some reason. That's going to give me the 5, reading left to right, it's a 5, then it's squared. Then we're going to take away, again, we're just reading left to right, 2 times the 5, and then it says take away 4. And that's a calculation. So this stuff here is just reading this here left to right, but wherever there's an x, we've put the 5 in, we've substituted in the 5. Now we can either use our calculators or our brains or our thumbs and our toes to work this out, but 5 squared take 2 times 5 take 4 is 11. Let's put that in black as our output. Okay, so 5 went in, 11 came out, so we get a coordinate of 5, 11. That's our first coordinate. We've got to do this a lot of times because we need coordinates all the way between here and here. Now, this is the bit in red that changes, which means the stuff in blue is the same every time. So I can pre-write some of this down to save me some time. So we're going to be taking away 2 times something and then taking away 4 to get an answer. Every time we're doing that. So we're taking away 2 times something, taking away 4 to get an answer. Now there's a lot of times to do this, because we've got x is 4. Oh, I've missed a bit. Did you spot it? What's happening to this first x here? It's being squared. So I should probably square these, shouldn't I? So the first time then it's 3, then it's 2, then it's 1, then don't forget 0, that's our number 2, -1, -2, -3. That's a lot of times you've got to do this. We've got to square it every time. We've got to take away 2 lots of it every time. And then take away a 4 at the end. Punctuation to make sure it's all literate. And our x values are 3, 2, 1, 0, -1, -2, -3. So that's quite a lot of work there. That's a whole page full of calculations that we haven't even worked out yet. Oops, sorry about that. So, notice that this is the same every time because the 2 and the 4 are the same every time. But the red value I'm changing because that's where the x's were, and that's the variable, that's what x is worth. I've gone from 5 to -3 because the question says 5 and -3. So these all need to be worked out now, which can mean it's a lot of calculator work or it's a lot of pen and paper work to get all these coordinates out. One thing I'm going to highlight, if you are using a calculator, depending on exactly how clever or good it is and whether you use the negative button or the subtract button here, these can go wrong on a calculator. So it's useful to remind it that the -1 is a number by itself by putting a bracket around it. So it helps the calculator out with its bid mass and stuff if you put brackets around negative values. because they're not as smart as they look all the time. So if we work these through, we get some values. 16 take 8 take 4 is 4. And these will just take a whole bunch of time to crunch through. So 3 squared take 2 times 3 take 4 is -1. 2 squared take 2 times 2 take 4 is -4. 1 squared take 2 times 1 take 4 is -5. This will be -4 because 0 and 0 and 0, and I happen to be able to do the rest of it quickly in my head because I might know a thing you should spot in a second. But those are all the values that come out if you put these through a calculator. And they are a lot of steps, that's just a fact. So we get some values out. So 4 went in and 4 came out. 3 went in, -1 came out. 2 went in, -4 came out. 1 went in, -5 came out. 0 went in, -4 came out. -1 went in, -1 came out. -2 went in, 4 came out. And finally -3 went in, 11 came out. So these are the coordinates we're going to plot, which means we're going to need some axes ready to go, and we're going to need to get these plotted accurately. So I'm going to do the axes in full for you to make sure you don't have any errors. I'm going to do it in pen, which is unusual. I prefer to do it in pencil so you can rub out mistakes, but I think the pencil won't come up very well. So I've got graph paper, squared paper will do. You've got your books hopefully taken home, you had enough reminders to do that. We have a highest value here of 11, in the y, got a y value of 11 there, and it doesn't get any higher than 11, so 11's the top, and the lowest it gets is -5. So I'm going to start actually up at 12, just above, and go down to -6 maybe, but make sure it covers the range that we need to do. And because this -3 to 5 isn't equally spaced either side of 0, I'm not going to start dead centre in my page. So I'm going to start at the top here somewhere with a 12. Now notice that 12, where it is positioned between the thick grid lines and your squared paper lines. It's not got a line running through it vertically, but it has got a line running through it horizontally. Now you can choose now to go up in 2s, up in 3s, up in 4s, up in 12s, whatever you want to go up in to make it fit neatly on the page. I think I'm going to choose 1 square is worth 2. So this will be 10, this will be 8, 6, 4, 2, 0. 0 counts, don't forget it, and the spacing has remained equal all the time. Then below 0 we've got -2, -4, -6, and because my lowest value was -5, I've now gone far enough. This is the y-axis, so draw it in, label it with a y and an arrow pointing which way is up. So that is the y-axis. Now this 0 tells me where the x-axis goes. So this is the x-axis, through the 0, cutting through the 0. And I think that should be enough, but I can make it longer if I need it later. So this is the 0 in the x-axis. This time it's being cut vertically. 1, 2, 3, 4, 5, 6, arrow, x, -1, -2, -3, -4. So in every case, these numbers are being cut with a vertical line, and these are being cut with a horizontal line, and these spacings are all equal along here, and these spacings are all equal along here. But they don't have to match each other. The x spacings need to match themselves, and the y spacings need to match themselves, not each other. So that's a coordinate grid ready to go. Bring back the coordinates, and again I prefer you to be using pencil here in case you make a mistake, but I have a feeling that the pencil might not show up clearly on the camera. So the coordinates are all here. I think they all fit on the screen nicely. Starting at the top, 5, 11 is 5 right, 11 up. That is there. 4, 4. 3, -1. 2, -4. 1, -5. 0, -4. -1, -1. -2, 4. and negative 3, 11. Notice that I'm using crosses, not dots for my coordinates. That's quite helpful because it means when you draw something through them, the crosses are still visible poking out the sides. So you'll notice this isn't a straight line, unlike previous things you've drawn before. They are clearly not in a line, which means you should resist the temptation to pick up your ruler. There is an exact curve that goes through these points, which you're going to do your best to do by hand. So the plan here, we'll see if I get it right, is to go through every point precisely in one single smooth curve, in one go, which can be a bit fiddly. Sometimes turning the paper round to match the shape of your hand is more useful. Sometimes it gets a bit trickier. So we're going to try and draw these points together in one go. Okay, so that's not brilliant. I've missed these two by some margin. So we might try that again and then use a rubber to correct it. That's a bit better. Okay, so that's a smooth curve. I'm going to get my rubber, which I had out earlier, and just get rid of this error here. So, it's a single smooth curve. We want to try and avoid these furry bits where possible. So that curve came from the equation y equals x squared take 2x take 4. And that's just the section that fits on our graph between negative 3 and 5. So this U shape you'll get quite used to being linked to these squared functions. So that was quite a page of work to get all those coordinates. I'm going to show you now a quicker way to do this. So you will need one of something like this. The FX85 works and the more advanced calculators work. Somewhere in your menu you will find a mode, if it's on, you will find a mode that is called table, which in this case is there. You can scroll to it or you can press the number that's labelled next to it and it pops up on the screen. And you'll get this f of x notation, which is something called function notation, which you won't need to worry too much about. But that essentially replaces the y. So y equals this in this question. So we're going to type that in here. So it starts with a 7, so it's 7 plus 5. Now what's the 5 doing to the x? Remember your algebra, that's 5 times x. You haven't typed x before, I don't think, on a calculator. There's these pink things, the alpha, which gets us the letters. You see there's a little x there in the pink. So if we do alpha x, we get the proper cursive x, and that means it will use it as the input. Take away alpha x squared. So that thing written there should match this thing written here. If it doesn't, you've typed it wrong. Hopefully that's clear enough on the screen for you all to see now. So, press equals. Depending on your calculator, you might not get this screen. If you do get it, leave it blank and press equals to skip it. We should all get to something like this, the start, end and step. So this question here is starting at negative 4. That's the negative button, not the take away button. So negative 4 equals, and 10 equals. The step is what it wants to go up in. So do you want to go up in ones or up in halves? How many coordinates do you want? We're going to go up in ones and press equals, and we get this table out. So it's now telling us that negative 4 gives us a result of negative 29 as its coordinate. We can just read those off as they are. So I'll do that now here so I have them easier to read. Negative 4, negative 29. Negative 3, negative 17, negative 2, negative 7, negative 1, 1, and then you can scroll down to the rest. We've got 0, 7, we've got 1, 11, we've got 2, 13, we've got 3, 13, we've got 4, 11, 5, 7, 6, 1, 7, negative 7, 8, negative 17, 9, negative 29, and that will do. So that's a lot of coordinates worked out there in one go. That would have taken a whole line of this working to get that one coordinate, another line to get that coordinate. So it saves you a lot of working out to get these coordinates. Make sure I can read that, that's a 5. So, some pre-drawn axes, as I said. Negative 4, negative 29 is down here. Negative 3, negative 17 is here. Negative 2, negative 7 is there. Negative 1, 1 is there. 0, 7 is there. 1, 11 is there. 2, 13 is there. 3, 13 is there. Some of you will have noticed that there is some symmetry in this, which means you can draw these things reasonably quickly once you get started and spot it. Okay, so again we've got these dots, these crosses that clearly aren't in a line, but this time the curve is already upside down, or N-shaped rather than U-shaped. And again we're trying to draw a single smooth curve as best we can through all of these points. It's not a best fit, it's exactly through these points, which can be quite tricky to do. But there it is, and that came from y equals 7 plus 5x take x squared. So, have fun with those. If you get a cube here or something else weird, the calculator works the same, the method works the same, the shape will be different though. It's always a single smooth curve. Have fun!